Hey Trick Class, in this homework set we're going to look at how to transform polar equations to rectangular equations and vice versa. So this is a polar equation, r equals 9, and that just means the radius is always 9 as we rotate. So the angle theta that would typically show up in a polar equation doesn't show up, and that means it's constant, so the radius never wavers as we rotate. That's just going to be a circle, right? But let's see, how do I get that circle? So the way that we're going to do it is we're just going to square both sides of this equation. So r is on the left. If we square the 9, we get an 81. And then we use the identity, x squared plus y squared equals r squared, which comes from just the unit circle, not the unit circle, a circle of radius r, centered at the origin. If I rotate out to some point, xy on the circle, there's the angle theta that I rotated. Well, r is the radius. And if I drop a perpendicular down from that point to the x-axis, I get a right triangle with that length x, that length y, and this the radius. And since the Pythagorean theorem holds on any right triangle, it holds on this right triangle with sides x and y and hypotenuse r. That's the identity we use. So this r squared is x squared plus y squared. So we get the rectangular equation that we're familiar with, hopefully, for circles, x squared plus y squared equals 81. So in this case, that's the squared radius. So when you see a polar equation with just r equals a number, it's just always x squared plus y squared equals the square of that number. That's the circle in polar form. All right, and you have to be careful because it asks, what is this that we're looking at? It's definitely not vertical lines or horizontal lines, but it's a circle, and the radius is not 81. It's the square root of that 81. It's the radius equals 9. And remember, r is radius. Radius is 9. And that's how you get that second part. Just make sure you don't fall into that temptation to grab that 81 number. All right, now this question is missing an r. Again, typically these equations are r equals a number or r equals something to do with theta. But sometimes only one of those variables is present. If it's r equals a number, that's a circle. If it's theta equals a number, though, that ends up going to be a line. And a unit circle helps here, but theta equals pi over 4 is a quadrant 1 angle. And if you recall, on that line theta equals pi over 4, you get things like the square root of 2, comma, the square root of 2 over 2, comma, the square root of 2 over 2. The x and y coordinates are the same. That's literally what this line's equation is going to be. It's going to be y equals x. So that literally is the line y equals x, and it means the y coordinate equals the x coordinate. And that's why when we look on the unit circle, we see the x and y coordinates are the same at pi over 4, and then down here at 5 pi over 4 as well. We get that the x and y coordinates are the same because both of those angles create that line y equals x. But how do we get it mathematically? Well, the way we do it is we take the tangent of both sides of this equation, and we get the tangent of theta equals the tangent of pi over 4, and the tangent of pi over 4 equals 1. Okay? And then tangent on a circle, it's defined by the y coordinate divided by the x coordinate. So this just becomes y over x equals 1. And then multiplying both sides by x, we get y equals x. That's the rectangular equation. It's equivalent to theta equals pi over 4. So we'll come down here and just write y equals x. And there's our rectangular equation. All right, what is this? It's a line in quadrants 1 and 4. Nope, it's a line in quadrants 1. That's our y equals x line. Then they have you graph it at the very end. Just use a graphing calculator if you don't know what the graph of y equals x looks like. But there's one I just drew. Right, pi over 4. That's that part of the line. If we kept going around, that'd be 5 pi over 4 would be the other part of that line. Just adding pi. That's the one that we're after.